Welcome to OmniEyes. Today we explore the incredible ocean sunfish and its amazing visual adaptation for extreme vertical underwater journeys. The ocean sunfish is a truly bizarre marine creature. It spends its life traveling between the bright surface and dark depths. Moving through these vastly different zones requires a highly specialized biological mechanism, especially when it comes to their massive, round eyes. At the ocean surface, the sun shines brightly. Down in the deep waters, sunlight vanishes completely, leaving only a pitch darkness. Navigating this extreme vertical commute is a massive challenge. The fish must constantly adjust its vision to spot both predators and prey. To survive these harsh environmental transitions, the ocean sunfish possesses an extraordinary pair of eyes that rival those of deep-sea giants. These gigantic eyes are perfectly positioned on the sides of its flat body, giving the creature a uniquely wide field of view. One of the most fascinating features of this eye is the highly flexible pupil, which reacts incredibly fast to changing light conditions. When basking at the bright ocean surface, the pupil quickly constricts to a tiny slit, protecting the sensitive inner eye from damage. As the sunfish dives deeper into the dark abyss, the pupil expands dramatically, allowing every possible photon of light to enter inside. This mechanical adjustment is just the beginning of the story. The true magic lies hidden within the complex structure of the retina. Scientists have discovered that the sunfish retina operates in a brilliant dual mode, perfectly engineered for two completely different marine light environments. In shallow waters, the retina relies on specialized cone cells. These cells process bright light and capture vibrant details of the surroundings. These cone cells ensure the sunfish can clearly see its environment during the day, easily avoiding dangerous predators lurking near the surface. But as the creature plunges hundreds of meters down, the cone cells become completely useless in the overwhelming darkness of the deep. This is where the second mode activates. The retina features an incredibly dense concentration of rod cells designed to capture faint light. Millions of these sensitive rod cells work together in the dark, absorbing even the smallest traces of bioluminescence or scattered moonlight above. Thanks to this extremely thick layer of rod cells, the sunfish easily detects the faint silhouettes of its favorite deep-sea meals. A jellyfish drifting in the dark becomes a clear target. The dense rod cells amplify the subtle contrast against the black water. What makes this visual system even more unique is the complete absence of any complex focal accommodation mechanisms found in other predators. Instead of actively changing the shape of its lens to focus, the sunfish relies on a brilliant alternative provided by natural evolution. The eye contains a perfectly spherical lens with a surprisingly high density, designed to bend incoming light rays with absolute mathematical precision. This spherical, high-density lens acts like a powerful wide-angle camera, capturing a massive panoramic view of the surrounding ocean environment. Because the lens bends light so effectively, the fish does not need complex eye muscles to constantly adjust its focus while hunting. This static but highly efficient optical design saves a tremendous amount of energy, which is crucial for surviving in the freezing depths. Every aspect of the sunfish eye is a masterclass in evolutionary efficiency, perfectly tailored for a life of constant vertical ocean travel. Looking closely at this gentle giant, we see a creature that has truly mastered the art of seeing in the dark ocean. The journey from the sparkling surface to the crushing black depths requires an eye that can conquer two completely different alien worlds. From the flexible pupil to the dual-mode retina, the biological engineering here is nothing short of an absolute miracle of nature. Nature has equipped the ocean sunfish with the ultimate optical survival tool, allowing it to thrive where many other species would perish. Imagine plunging into total darkness with eyes that automatically switch their biological sensors to detect the invisible shadows of your hidden prey. This is the daily reality for the magnificent ocean sunfish as it embarks on its endless vertical migration through the vast blue. The transition between the cone cells and rod cells happens seamlessly, ensuring the fish never experiences a single moment of complete blindness. Even in the twilight zone, where sunlight barely penetrates, the spherical lens gathers enough visual data to safely guide the journey downward. Scientists continue to marvel at how such a seemingly clumsy animal possesses one of the most sophisticated visual systems on our planet. The large spherical lens sits perfectly within the eye fluid, refracting light to create a comprehensive visual map of the dark depths. By eliminating the need for complex focusing muscles, the The sunfish allocates its limited energy towards swimming and regulating its core body temperature. In the freezing waters of the deep ocean, every calorie matters. The static optical design is a brilliant biological energy-saving strategy. As the fish ascends back to the surface to warm its massive body, the visual process reverses itself with perfectly timed precision. The pupil quickly shrinks, the dense rod cells deactivate, and the bright cone cells take over to process the intense sunlight above. This continuous cycle of visual adaptation happens every day, keeping the ocean sunfish perfectly attuned to its ever-changing vertical marine environment. Without this incredible dual-mode retina, the sunfish would be completely blind during deep dives, making hunting impossible and starvation highly likely. Evolving this massive eye directly responds to the unique challenges of a life spent moving between extreme and completely dark ocean depths. This exemplifies how natural selection shapes anatomy to overcome the difficult environmental barriers found throughout the mysterious and vast, deep ocean world. The high-density spherical lens acts as the ultimate light-gathering tool, maximizing the efficiency of every photon that enters the eye. Even the faintest glimmer of a distant glowing jellyfish is captured, focused, and translated into a clear visual signal for the brain. The sunfish might resemble a giant head, but its sensory capabilities easily rival those of the most advanced deep-sea marine hunters. Understanding the mechanics of the sunfish eye gives researchers valuable insights into how vision evolved in the darkest corners of our planet. Every time this majestic creature dives into the abyss, it relies on millions of years of optical refinement to guide its journey. The dense layer of rod cells is a biological masterpiece, absorbing dim light to reveal the hidden secrets of the deep ocean. While humans need artificial lights to explore crushing depths, the sunfish simply opens its massive eyes and lets nature take full control. Seeing clearly in both glaring sunlight and absolute darkness is a rare trait, making the sunfish a true marvel of marine adaptation. These eyes perfectly reflect its extreme lifestyle, bridging the gap between the bright sunlit surface and the mysterious dark midnight ocean zone. This spherical lens bends light to maximize the visual field, helping the fish quickly spot dangerous threats from almost every single direction. Wide-angle vision is vital for survival, because the slow-moving sunfish cannot rely on speed to escape from fast marine predators. Instead, it uses superior optical awareness to detect danger early and maneuver its massive body out of harm before sudden disaster strikes. The fascinating biology of the sunfish eye proves that evolution always finds incredibly creative ways to solve complex environmental survival problems. By studying these massive eyes, we gain a deeper appreciation for the delicate balance of life existing within our vast global oceans. Every component, from the flexible pupil to the dense rod cells, works in perfect harmony to support the extreme vertical journeys. Without this flawless biological synchronization, the massive ocean sunfish would be unable to navigate the treacherous depths of its vast aquatic home. The visual journey of the ocean sunfish is a testament to the incredible resilience and adaptability of marine life in extreme environments. As the sunfish dives deeper, the pressure increases immensely, but its strong spherical lens remains perfectly intact, maintaining its precise optical shape. This structural integrity ensures that the fish never loses its ability to focus on the faint shadows of its deep-sea prey. The dual-mode retina acts like an advanced biological camera, automatically adjusting its exposure settings to match the surrounding ocean light levels. When the fish spots a cluster of jellyfish in the dark, the dense rod cells immediately lock on to the faint glowing targets. The spherical lens bends the dim light rays, concentrating them directly onto the thick layer of sensitive rod cells for maximum visibility. This highly efficient optical process allows the sunfish to feast on deep-sea creatures that remain completely invisible to many other predators. After a successful hunt in the freezing darkness, the sunfish slowly begins its long vertical ascent back toward the warm ocean surface. As the water becomes brighter, the sensitive rod cells gradually deactivate, protecting themselves from the overwhelming intensity of the incoming bright sunlight. Simultaneously, the specialized cone cells awaken, ready to process the vibrant colors and sharp details of the shallow, sunlit marine environment above. The flexible pupil rapidly constricts, creating a tiny, protective aperture that shields the delicate inner retina from the harsh glare of sunlight. This seamless transition between two entirely different visual modes is what makes the ocean sunfish such an incredibly successful vertical marine traveler. Biologists continue to study this unique optical system, hoping to uncover even more secrets about how vision functions in the deep sea. The high-density spherical lens is particularly fascinating, as it offers a brilliant biological solution to the complex problem of underwater focusing. By relying on a fixed, highly refractive lens, the sunfish avoids the metabolic cost of constantly flexing eye muscles in the cold. This energy-saving adaptation is crucial for a creature that spends so much time hunting in the freezing depths of our oceans. The massive size of the eye itself is another key factor, allowing it to capture the maximum possible amount of available light. In the deep ocean, where every single photon is precious, having a giant eye is a massive evolutionary advantage for any predator. The ocean sunfish perfectly combines sheer size with advanced optical engineering to conquer the challenging vertical gradients of its vast marine habitat. From the sparkling blue surface to the pitch-black abyss, this gentle giant navigates its world with unparalleled visual precision and grace. The intricate design of its retina showcases the extraordinary power of natural selection to optimize biology for highly specific and extreme environments. Every dive is a complex visual symphony, with the pupil, lens, and retina working seamlessly together to illuminate the dark ocean depths. The sunfish reminds us that even the most bizarre-looking creatures often possess hidden biological superpowers that allow them to thrive beautifully. Its massive eyes are the ultimate windows into a dark world that remains largely unexplored and completely mysterious to human scientific observation. As we continue to explore the oceans, the sunfish stands as a shining example of deep-sea adaptation and biological optical perfection. The next time you see an image of this strange fish, remember the incredible visual technology hidden within its massive round eyes. It is not just a drifting giant. It is a highly evolved master of vertical migration, perfectly equipped for its extreme journeys. The dual-mode retina and high-density spherical lens are biological marvels that continue to inspire awe and fascination among marine researchers. Through the eyes of the ocean sunfish, we gain a unique perspective on the profound challenges and wonders of deep-sea survival. This magnificent creature has conquered the vertical ocean commute, using its advanced vision to bridge the gap between light and absolute darkness. The story of the sunfish eye is a beautiful reminder of the endless creativity and resilience of life on our blue planet. From the surface to the abyss, the ocean sunfish sees it all, guided by an optical system forged by millions of years. We hope this deep dive into the visual mechanics of the ocean sunfish has given you a new appreciation for this giant. Nature never ceases to amaze us with its brilliant biological solutions to the most extreme environmental challenges found in the deep ocean. Thank you for joining us on this incredible underwater journey to explore the fascinating visual adaptations of the magnificent ocean sunfish today. We will continue to bring you more amazing stories about the hidden wonders of the natural world in our upcoming educational episodes. Until next time, keep exploring the mysteries of nature, and thank you for watching OmniEyes. Goodbye and see you very soon.